So good Thursday afternoon, everyone. Welcome to lecture 4, Mathematics for Construction. Just a quick review of what we did last class. Last class was lecture 3. This was last week. We talk about basic algebra. Algebra is really for you guys, right? For you guys, algebra is really representing unknown quantities using letters, okay? As an unknown, like let X be something, okay? When you have letters and numbers and signs, it tends to give people a lot of problems, okay? When you're trying to simplify things. We talk about terms, hidden items, right? Like 7 is not just 7, it has a lot of invisible things around it. There are like terms and unlike terms, right? How to add and subtract them. We did examples of that. You're really dealing with the coefficients once you realize the terms are like terms. I have no subtraction, really, no operation called subtraction is really adding negative numbers, right? And then we had some questions where we practice, collecting like terms together. And, you can't do anything with these two here. They're not like terms, but you could simplify 13x squared y and 23 and 7. Let's deal with the coefficients, right? We talk about expression. Every term is an expression, but not all expressions are terms. Like 12 is a term and an expression, but 3x plus 2y is an expression. That's not a term. That's two terms, the sum of two terms. Sometimes you use brackets, but be careful with that, right? Don't introduce brackets in a question. You could change the question and get it wrong. Okay, to be very careful not to introduce brackets in questions. Sometimes it's okay like this here, but when you have negative signs, you have to be careful. And we did plenty questions here where we expand and simplify. When I say expand and simplify, they really mean multiply it out, collect like terms together and add them up, right? So like this example here, it have a bunch of m squared and an nm squared and so on, but we collect them together. You see the 15, the 54 and the 7. When we add them up, we get 76. And these guys here, the 20, the 48 and the 40, these last 3 terms here are like terms, so you combine them into one. Now, this is not a final answer in advanced mathematics. You still need to factorize this, which we will talk about today, right? But I think we pretty much understood these examples here. And we had a quiz exercise, right? If you go on the homepage for the course, you see there's a worksheet here, algebra, expand and simplify. You could do this and send me a private WhatsApp message of with your working, right? Take a screenshot of your page, your pencil and pen working, and you could just, if you want, you may not sure about a certain question, just do it, take a screenshot and send me and ask me, right? The feedback is good if you're not sure what you're doing. If you're very confident and you know you're gonna get all of this right, then you don't need to show me anything. This is not for marks, right? You're not in secondary school. This is for you to do, for you to gain practice, right? Not to get marks. I'm not checking it or anything like that. What we want to do today is focus on improving from where we left off. We left off here. We want to improve and grow from that point, right? So some time ago, lecture 2, we saw how to find the HCF and LCM of 2 numbers, right? So if you go back to your lecture 2, you'll be able to see example 3. Before we started algebra, we talk about how to find HCF and LCM. HCF is the more important thing for now, right? What we want to do is we want to find the numbers that are common to all the terms. So like 210 and 315, not very big numbers, right? But 3, 5, and 7 is common to both these numbers, okay? So we find common factors, right? You find common prime factors and you multiply them, okay? And there are many different processes where you could find the prime common factors of 2 or more numbers, right? This tabular method here is very easy. We want to extend this So finding the HCF of not only numbers, but algebraic terms, okay? So how do you do that? So HCF of algebraic terms, that's what we want to talk about now. We know to find HCF for two numbers, but what happens when we have letters and terms and expressions, okay? How would you do that? You can find the HCF of two or more terms by following some simple steps, okay? And just like with expansion, you focus on the sign, you focus on the number, and then focus on the letters, okay? So if you have two or more terms, you'll see an example just now, right? What you want to do is, if all the items are negative, then the HCF of all the terms would be negative. Otherwise, the HCF is positive. That's the first rule. Second rule, the HCF of the terms would have a number component, and the number component is the HCF of the coefficients of all the terms. And then the letters, the HCF will have letters, or may not have letters, but if it have letters, the letters would be the product of the lowest power of each letter common to all terms, okay? I think you ought to see an example of this, right? This is very abstract if you think about it. So let's find the HCF of these three terms here, okay? How would you go about that? Well, we follow the rules from above here. You start with the sign. The sign of the HCF is positive, since all the terms are not negative. Only when all the terms are negative will the HCF be negative. So the HCF is positive, okay? What about the number? What about the number? We follow the rule. We look at the number component of the HCF is equal to the HCF of all these coefficients here, 12, 18, and 30. How you find HCF for 12, 18, and 30? Okay. We use the tabular method from this lecture here. So let me see if I could copy this, put it here. And change up my numbers. 12, 18. And 30. And we don't need the LCM. And we need to do the prime factorization at each number here. These numbers, let's take them out. Leave the x's because that's multiplication. Don't know what it says here. What is the prime factorization of 12? Right? 12 is 3 by 4. Okay, it don't matter how you break it up. They will end up with the same prime factors. 4 is 2 by 2. So this is 2 by 2 by 3. That's the prime factorization of 12. 18 is 3 by 6. Which 6 is 2 by 3. So this is 2 by 3 by 3. Right? 2 is a 6, 3 is a 18. 30 is what? 3 by 10. And 10 is 2 by 5. So this is 2 by 3 by 5. Prime factorization, right? So up here, I would probably write the 2 by the 2 by the 3, right? For 18, I would put, well, 2 by the 3 by the 3. right? For 30, 2 by 3 by 5. So I could put a 2 here, a 3 here, and a 5 here, right? So what is common? What are you seeing common here? Right? The 2s are common, right? So the 2 is common, so I put a 2, the HCF will have a 2. And the 3 is another common one. Put purple for that. Okay. So I'm really gonna have a 2 and a 3. So this is a 6. Right? Multiply the common numbers to get 6. So the HCF is 6. So I could say here, we could conclude here, down here, the number component of the HCF is 6. Okay. So the HCF of these 3 terms is a number or a term, is a term, right? Is another term. If we have 3 terms and we want to find the HCF of these 3 terms, the HCF of these 3 terms is another term. A term may or may not have a sign and may or may not have a number, may or may not have a letter. But we realize now the HCF of these 3 terms, it's positive and the coefficient is 6, right? What about the letter now? The final part is the letter, okay? So the letter part now, we need to look, remember the rule here, the lowest power of each letter common to all the terms. What letter is common to all the terms? Have a X, a X, a X. So X is common, right? And there's no other letters. So what is the lowest power of X you see here? I have X squared, I have X, and I have X3. So X is the lowest power of X. So the only letter common to all 3 terms is X. My lowest power of X is 1. So the HCF will just have X to the power 1 as the letter component, right? And therefore, you can write, you could summarize this here by saying, well, the HCF of 12x squared, 18x, and 30x cubed will be positive 6x. Okay? That's what they ask us to do ultimately. With that in mind, tell me if you think you want to try this example here. We have 3 terms here in example 2. We want to find the HCF of these terms. Okay. First of all, let's work out the sign. Sign of the HCF is positive since all the terms are not negative. Right? You could work out the HCF without the tabular method. Right? This is an example here. The number component of the HCF is the HCF of all the coefficients, 5, 15, 20. If you do the prime factorization of 5, 15, and 20, you see all of them, the only thing they have in common is 5. And that should be easy because 5 is a prime number. So the only HCF you could have get is either 5 or 1, right? So that takes care of the number part. What about the letters? What about the letters? Which letters are common? X is common to all terms and Y is common to all terms. So now that we realize that X is common, what is the lowest power of X that you see? That is 1. See X to the power 1 by the 5. So the HCF will have an X1 term on it. What about the y? It's a similar story, you know. Y is common to all three terms. The lowest power of y we see is 1, so the HCF will have 1 in it. And then we just multiply everything. The sign is negative, is positive. So it's positive by 5 by x by y. Okay. So the HCF is positive 5xy. Try another example, right? Just to get some practice, right? Because that's why we come to class, right? To get practice. Class is not just about notes. You have all the notes here. You don't have to write anything down. I've given you all the notes. Fast as I type in, you have notes. But figure out this one. It shouldn't take too long. We have 3 terms again. We need to examine the sign. So I probably needed to put a solution. Take a left this out. Solution 2. Solution 3. So again, you work out. They have these steps in it, right? You work out all of them are positive, so the HCF is positive. Look at the numbers. What's the number in front of this first term here? Because you have no number, 1 is understood. No, now the HCF of 1 and anything is 1, right? So it kind of, this one is a little bit easier. The HCF of all the coefficients is 1. Right? Then what about the letters? Which letters are common? A is here, here, and here. So A is common, right? Is B common to all 3 terms? No, the middle term doesn't have B. So B could not be in the HCF, okay? So when you multiply all these things together, positive by 1 by A, the HCF of these 3 terms will be positive 1A. And you don't really write it as positive 1A, you just say A, right? You just say, well, you know, is equal to A, right? You don't typically put your answer as positive 1A, but you get the idea, right? Hope you all understand this. I hope you all get it. That was like a trick question in a sense. What about this one, right? Find the HCF of these 3 terms here. Similar fashion, right? These 3 terms here, we need to follow the process, right? All of them are positive. So the sign portion of the HCF will be positive because they're not negative. If you look at the numbers, the coefficients, right? Coefficients could be broken up into prime numbers. So 40 is 2 by 20, 20 is 2 by 10, 10 is 2 by 5. So 3 2s and a 5. 16 is 4 2s, right? And 24 is 6 by 4. So 4 is 2 by 2 and 6 is 2 by 3. So if you notice in bold, how much prime factors are common? I have one group of 2s, another group of 2s, and another group of 2s. So it's 3 groups of 2s that are common. So you multiply 2 by 2 by 2, the HCF would be 8. And what about the letters? A is common to all letters, okay? All terms, sorry, A is common. What's the lowest power of A you see? A 2, a 2, and a 2. So then that means, you know, you're gonna have a squared, right? The HCF will have a squared. So far the HCF is positive 8a squared. What about the B? Is B common? Yeah. Okay, good. So B is common. What's the lowest power of C? I'm seeing a 2, a 3, and a 4. So let me write a 2. Good stuff. And then C. C is common. And the lowest power is, let me see, 2, 3, 4. So 2. So C squared. And we state that here. So now when we multiply everything, positive 8a squared, b squared, c squared, we will get HCF of those terms is positive 8a squared, b squared, c squared. And you don't need to write a positive sign. I just put in it there to show you that I had a thought process where I was thinking about the sign, and you know, actively thinking about the sign. But a lot of the times the HCF is be positive because it's only when all the terms are negative will the HCF be negative. Okay. Hope you all understand this. So if you could find the HCF of a bunch of separate terms, then it's not that stretch of the imagination to find the HCF of a expression. Okay, how do you find the HCF of an expression? Well, expression has several terms. To find the HCF of an expression, we just find the HCF of all the terms like we were doing up here, right? So if I have this expression here, I just put spaces to separate them, right? I have 9 by something minus 21 by something plus 6 by something. What's the HCF of this expression? That's what I'm asking you. Well, what you had to do is find the HCF of each of the terms, just like you was doing before. So I'll try this question now and tell me what you think, if you could figure this out. Okay, yes, treat it like if the terms are separate. The terms in the expression treat it like it was separate, and take care, look at the sign, the number, and the letters. We have expression this time, and we want to treat it, you know, as a sum of 3 terms. There's really 3 terms being added here. We look at the sign again. If the sign has to be, all the terms have to be negative for the sign of the HCF to be negative. What about the number 9, 21, and 6? What is the HCF of 9, 21, and 6? Again, prime factorization. 9, 21, 6. Right? 9 is 3 by 3, 21, 3 by 7, 6, 2 by 3. 3 is the only thing I'm seeing common here. There's only what they are one time. So the number component of the HCF will be 3. What about the letters though? A is here, A is here, A is here. So A is common. B, so B is common as well. C, C, C. So A, B, and C are common. So that discussion, I mean, there's a discussion you're doing in your head, right? For the letters part, right? And therefore, your HCF of your expression is really what that is here. Positive by 3 by A by B squared by C. Okay. Now nobody gonna give you a question asking you to do this and you have to write out all of this for me. This is a building block topic. This is like adding fractions. Nobody gonna give you fractions to add, and when you add it, you're done, right? We building skills. This is a small skill that is necessary for more important skills coming up the road. Okay, so don't. I'm just giving you this full discussion here to explain what I'm doing. But you're never going to be given a question like this where I just say, oh, you have these three terms here, find the HCF. That's not a question. That's one line in a 35 line question. Okay, this is like one line in a 35 line question. So we just building core skills at the moment. Let's give you, try this example here. Okay, example 6. Find the HCF of this expression here. Okay. This expression is probably the first expression where the sign of all the terms is negative, right? So the HCF of these, well, the HCF of this expression has to be negative, okay, because all terms are negative. What about the number? You have to take your time with those numbers, and not exactly small. We break up 39, 52, and 65. We try numbers, right? There's a science behind it, you know. Like this number here, 52, is I mean, we could say 2 by 2, right? But these numbers, the 39 and 65 is not even, so they don't make a difference if I put the two twos, right? It turns out they're all multiples of 13, so the HCF is 13, right? What about the letters now? It's the same thing as before. X, so X is common. Lowest power of X is, let me see, 4, 3, 5, so 3x cubed. Y looks like it's common. Z looks like it's common. So lowest power of Y is what? 2. And lowest power of Z is 1. So essentially, you have 13, negative 13, right? Negative 13 by x cubed y squared z. And this is just the justification here that I've given you, just to make you understand where I'm getting all of this from. But the answer is negative 13 x cubed y squared z. So hope you all understand this. Let's move on to something new. Let's talk about expressions in factored form. So if I give you an expression without brackets, you could write it in a form that has brackets, where you factor out some common multiple, or some common, not multiple, some common factor, right? So let me give you an example. Look at this. 12x squared y squared minus 6y xy. 2 is a common factor, okay? 2 is a common factor. So I could write this in brackets where 2 is on the outside, and I will get back the same thing. If you expand it, right? 2 by 6 is 12, and 2 by negative 3 is negative 6. This is a factored form of the original expression. We could do other forms, right? Like, what is another factor of these two terms here? Give me another number that is a factor of these two terms here. Anybody? I'll give you 2. What's another factor, 12 and 6?
3.
3, right? So I could write the factored form like this. Same expression, but I could write it a different way with 3 on the outside here. And there are letters that are common as well. Like there's a x squared and an x, there's a y squared and a y, right? So I could say, well, you know, 2x is common, and write this, okay? it's a different factored form, but when I multiply the second line, I get back the first line. 2 by 6 is 12, x by x is x squared, y squared is there. 2 by minus 3 is minus 6, x by y is xy. You know, I'm getting back the same thing. And I could try 3y. 3y is common because y is there in both terms and 3 is common to the both numbers. So I could factor out a 3y and I get this. And I could keep going. How far can I go though? That's what I'm asking you. How far? What is the largest factor I could put on the outside here, both in terms of letters and powers? Powers are letters and numbers. What's the biggest thing I could put on the outside here? Well, the largest thing that could be on the outside here, first of all, is a factor, right? It's a common factor. And I want the highest. So I think you understand where I'm going with that. The highest common factor of the terms could go on the outside here. Is it? So essentially, I will get something like this. And now we see the role of HCF. Okay. HCF is used. All these are common factors here. 2 is a common factor, 3 is a common factor, 2x. But what's the largest common factor, the highest common factor? Well, that's what we're doing for the past hour, right? The HCF of these two terms here is the HCF of the coefficients and the letters. So the HCF is positive because there were mixture of signs here. The HCF for 12 and 66. X is common, the lowest power of x you see is 1, and the lowest power of y, which is common that you see, is y. Right? So that's the HCF on the outside. Now, if you put the HCF on the outside, what would you need to put on the inside? And it's a kind of game you have to play, right? I would do it like this, right? I have something and something. I have two things inside here. The HCF is positive, so between the question marks, I'll have minus, right? Now, 6 by what is 12? Well, I need a 2. X by what is x squared? I have an x on the outside. X by what is x squared? I need another x. And y by what is y squared? I need another y. Okay, and this 6xy by what is 6xy? Well, 1. And you're done there. Okay, so given an expression, we should be able to find the HCF, put it on the outside, and figure out what we need inside to multiply. Okay, so I could give an expression here. Let me give you another example. Look at this expression, right? 10p cubed q squared plus 20p squared q cubed. Now I could pull out a factor of 5p, but you know, what is the largest factor I could pull out on the outside here, right? Who could tell me? That would be the HCF, right? What's the HCF for these two things here? So let me cancel this order here. I need HCF by something plus something. And I know the HCF going to be positive, so I'll put it on the outside here. And I'll have a positive between the two terms in the brackets, right? What is the HCF of these two things? Who could tell me? You could do it by eyesight. By now you could do it by eyesight. What's the HCF for 10 and 20? Do the sign, then the number, and then the letters. So the HCF, it will be 10. What were the letters? Is P common? Yeah. Is Q common? Yeah. What was the lowest power of P?
Square.
Squared. And what is the lowest power of Q that you see?
Square.
Right. So that's the HCF. Now, if that's the HCF, right? What goes inside the bracket so that I will get back this original expression up here? 10 by what is 10? Well, I'll power 1 for now, right? P squared by something is P cubed. So I would need a P there. So let me take out the one and write a P. Yeah. And Q squared. Well, I have Q squared and I need Q squared. So I'm good. I'm done. Right. Let's go to the next term now. Start with sign, then numbers, then letters. So plus by plus is plus, 10 by 2. 10 by 2 is 20. I have a P squared already, so I don't need any more P's. I just need a Q. Very good. Is it? And do you know what this process is called? Anybody? What's this process called? Is cause students to tremble in fear. Right? That's what we call that's what I take a whole hour and a half to teach you. That is what factorization really is. Is finding the HCF, putting it on the outside, and then figuring out what you need inside the bracket so you could get back the original question. Right? It involves systematically finding the HCF, right? So given an expression of several terms, you could represent as a product of the HCF and some other expression. The other expression is the stuff in brackets. You follow? So let me give you like an example, another example, right, to work with. I have this example 3 here, where I have an expression, but I decided to pull out -3. But that's not the real answer. This is not the correct answer here, right? So you tell me what the correct answer is for that. And let me see. Let me try to do, let me give you 2 one time to do example 4. And what I could give you, boy. Give you this, right? So I have 2 problems. And they're gonna ask you, there's like, well, factorize this. You know, and most students will be like, what how you just do that again? Like how you just know what to put on the outside? How you just know what to put on the outside? I answer that question for you. Put the HCF. You all know how to find the HCF. The HCF is what goes on the outside. The largest common factor is what you put on the outside the bracket. And then you figure out what you need inside the bracket. So do this for me now. What we do is we have to set up the answer, okay? The answer is we write it HCF into something, and 2 things, okay? So I could put a space. I could put like a space between them. It says HCF by something and something else. 2 things. Let's figure out the HCF part. HCF, I have a sign, a number, and a letter. That's the algorithm, right? That's the order we're going. Sign, number, and letter. Both these things negative, so the HCF is negative. What's the HCF of 6 and 18? 6 could go into 6, and 6 could go into 18. 6 is the HCF. Highest common factor of both these numbers. What letter is common? A is common. The lowest power of AIC is, well, A. And I have B cube and B. So B is common, and the lowest power of BIC is B. Okay? So we're done with that. That is the HCF, minus 6AB. Now we're gonna figure out what these 2 question marks are. The first question mark, negative by something is negative. Again, you're working sign, number, letter, right? So negative by what is negative? Well, I don't need a sign here, but it could be positive for now, right? 6 by what is 6? Well, 1. So I write positive. I write a positive 1 for now, right? A by what is A? Well, 1, positive 1. B by what is B cubed? I need a B squared. I need a B squared. So you know what? I could just, that plus 1 kind of invisible. I could just take it out, okay? So B squared is the right thing I need there. What's the next question mark now? Minus by what is a minus? Minus by a plus is a minus, right? 6 by what is 18? 3. A by what is a squared? Well, another a. And b by, I have a b. I don't need any more b's. So let me just take out these spaces here and great, that's my answer. You see, as a systematic way, take your time. Signs, numbers, letters. That's the order. That's the order for finding the ATF, and that's the order for multiplying to get back what you need. And you're checking systematically the sign, the number, and the letter. Let's go again with this one. Set it up. HCF, open bracket, close bracket, question mark, question mark. Right? This is my answer here. Both terms are negative. So the HCF will be negative. Again, HCF on 9 and 27 is 9. 9 3s are 27. X is common and Y is common. So I'll have an X and a Y. But let's see the lowest power of X. I have X cubed and X squared. So I need an X squared in the HCF. That's the lowest power of X. I have a Y squared and a Y cubed. So I need a Y squared. Right? So that's it. HCF done. Sign, number, letters. Right? We do the same thing now. Sign, number, letters. What sign I need in the first question mark? Well, I need a plus sign. Minus by a plus is a minus. I need 1. 9 by 1 is 9. Number now, that's what I do it. Now I'm going to do the letters. X squared by what is X cubed? X and Y squared. I already have Y squared, so I'm done. So I'm not going to write positive 1X. I'll just write it as X, okay? Definitely need a plus sign here because a minus by a plus is a minus. 9 by what is 27? Number now, 3. And then the letters. I have an X squared and I need an X squared, so I don't need any more X's. But I think I need a Y here. Y squared by Y is Y cubed. And when you're done, take out all these signs, so space, and voila. That's the answer, okay? Easy squeezy factorization. You just have to understand the steps. There's a logical sequence of steps to do this thing. Once you do that, you shouldn't have any problems, right? So let me give you some more examples here, right, for you to try. You have to practice this thing, you know. You have to practice this thing. So let me see. Block equation. So factorize this. What I'm gonna do is duplicate this. Yeah. Give it 3 questions. So this is 5, this is 6, this is 7, right? And each one gonna be a different question. So example 6 is this. Factorize that. Example 7 is something a little bit longer, right? Looking a little bit more scary. And these are the kind of easy questions in a sense, because you don't have to expand and think. They just give you an expression until you factorize. The other questions is where they give you things and you have to expand and simplify, and in the last you factorize, right? So example 8. That's that. Give you an example 9 as well. So I have 5, 6, 7, 8, 9, right? And then we'll move on to the harder things when we done do all of this, right? So You have it there. You have it in your notes. You could sit down and start simple with 5 and move on to these other questions here. And these questions might look familiar to you. Some of them might look familiar, right? So have fun with this. So we starting with number 5. We want to write the HCF by, you have 2 things inside here, right? So the signs are mixed, so the HCF will be positive. What's the HCF for 12, 18, and 30? 6 2s are 12, 6 3s are 18, and 6 5s are 30. So HCF looks like 6 here. What about the letters? X is common and the lowest power is X. So there's actually there's actually 3 things, right? 3 things that are going inside here. So we go with sign, number, letter. 6 by what? Positive by positive is positive. So this will be positive. 6 by 2 is 12. X by X is X squared. So I could take out the 2. Positive by a minus is minus. 6 by 3 is 18. And don't need another X, okay? And for this one, 6 by positive 5 is 30, and I need an X squared to get the X cubed. So that looks like the answer there. Number 6. Right. HCF by something. The HCF can't be bigger than 5 because one of the numbers is 5, right? X looks common, so the lowest power is 1. And Y looks common, the lowest power is 1 as well. 5 by positive 1 is 5. This is what I have so far. And X by 1 is X. So I need a Y squared here. Need a Y squared there. Now 5 by negative is negative 3 is 15. I need a X squared. Already have a Y. So I don't need an extra Y to get this Y. So this looks good. And then 5 by 4 is 20, negative 4, right? I need a X squared, right? X by X squared is X cubed, and Y by Y squared is Y cubed. So this looks like it there. Number 7. HCF. Oh. Right, so HCF and 3 things. Now all the terms are negative. So yay, the HCF is negative. 40, 16, and 24, that's 8. Because 8 2s are 16, right? 8 3s are 24. So 8 is the biggest thing that is common. A is common. What's the highest? What's the lowest power of A is C there? 2. B is common, lowest power is 2. C is common, lowest power is 2. All right. This feeling familiar though. 8 by 5, negative 8 by positive 5 is negative 40. I don't need any A's. I have a A squared, I have a B squared, I have a C squared. Oh, so it's just 5. All right. 16, I need a 2. Negative 8 by 2 is 16. Yeah, positive 2. I need no more A's. I already have 2 A's, but I need an extra B to get a B cube. I have B squared here. B squared by B is B cube. C squared by what is C cube? I need a C. Right? So we go there. What we need again? 8 by plus 3 is 24. A squared by 1 is A squared. B squared. I need a B. Need a B squared to get a B4. And the same thing with C. I need a C squared as well. C squared by C squared is C4. Great. Number 8, I could give people a lot of trouble, but I don't know why. A lot of people made errors here. HCF. Something. 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 3 terms, 3 things in the brackets and an HCF on the outside. 9, 21, and 6. 6 is now factor 9, so it had to be something less than 6. We could try 3. 3 is in next factor less than 6. That is a factor 6. 3 could go in all of these here. So the HCF has to have a positive 3 because the signs are mixed. 3 by what is 9? 3 by 3 is 9. Oops, we have A is common, B, and a C. What's the lowest power of A? 1. What's the lowest power of B squared? What's the lowest power of C? 1. Right? So this is 3 by 3 is 9. I already have an A. I need a B squared, and I need a C to get a C squared. This would be positive. 3 by 7 is 21. I need 2 A's, but I have 1 A. So I need another A here. B squared by B squared, C by C squared will give you the C cube, right? All right. Need a minus sign here now. 3 by 2 is 6. And I need an AB. Okay, because I'm looking at what I have and what I need. So A by A is E squared. B by B is B cube, and C by 1 would be C. So that's 8 there. This question is looking familiar. I feel like I do this already. It's here. Something, something, something. Right? What is the HCF? First of all the terms are negative. So this is minus. 39 is 13 by 3. So you know that HCF is 39 because this is a 13 multiple and this is a multiple of 13 as well. Our x, y, z. This is the lowest power of x you see there. 3. Y squared. I have a z to the power 1. So definitely the HCF has z. All right. 13 by 3 is 39. Positive 3 because the negative 39 outside. I have 3 x's, but I need 1 more. So that's x. I have 5 y's. Well, I need 5 y's, but I have 2. So I need a y3 here. I need 2 z's, but I have 1 z. So I'll put a z. Okay. As that. This one is positive 4. 13 by 4 is 52. I need x cube, I have an x cube. I need y squared, I have a y squared. I need z4, but I have a z. So this would be a z cube. And the last one, definitely gonna be positive. Or I'm gonna be positive because I pull out a minus sign in the HCF. Right? Now this is 5. 13 by 5 is 65. X cubed by x squared is x5. y squared by y is y cubed, and z by 1 is z. All right. So this looks like the answer for number 9. All right, and that's it for now. Hope you all got this. So nobody really ever going to give you a question like this, okay? But they just give you an expression until you factorize. Questions start a little bit ambitious, you know. This is more like a past paper question here in say CSEC, right? But this is still a very easy question. This is still a very easy question here. What I need you to do is expand the brackets, then simplify means collect together like terms, and that final expression you get, you need to factorize the final expression. So this is even more work than the others up here. You need to pay real attention to your signs here, man. All right, so try this, have fun. We was doing this in lecture 3. In lecture 3 we was doing this, right? Lecture 3 we were multiplying things out like this problem here. We was multiplying things out, right? So we get some practice with lecture 3. That was last lecture, right? So now your final answer, you want to factorize your final answer. So have fun with this. One way of tackling this problem is to just take your time, right? 2 3s are 6. X by x, x squared. Y by y squared, y cubed, okay? 2 by minus, that is minus 2 4s are 8. X by x squared is x cubed. Y by y is y squared, right? Minus 3 by plus, that is minus 3. The x squared comes along for the ride, and I have a y cubed, right? Y squared by y is y cubed. Now minus by minus is plus, right? So that's a plus. 3 4s are 12. I'll have that x cubed here, and I'll have the y squared. And then this 2 kind of just comes along for the ride. 2x cubed y squared. Now we want to collect like terms together. So you basically rewrite the question and just rearrange them. So I'm going 2 3. So because you write it in alphabetical order, x before y, you can just look at the order of the powers. So 2 3, 3 2 no, 2 3. All right, so it's just the 3 is the 2 3 as the x squared y cube, right? These two are like terms. Right, so you basically take this 3 here and put it here, and the 8 just comes here, and you have all that stuff there. Now the terms are grouped, you just add the coefficients. So 6 minus 3 is 3. Right? And we have negative 8 plus 12. Negative 8 plus 12 is what? These 3 terms are like terms here. So negative 8 plus 12, that's 12 minus 8, which is 4. And then 4 plus 2 is 6. So that's 6 of these guys here. 6x cubed y squared. All right. Now, this is a okay final answer, but you need to factorize. So this is not finished yet. We have a HCF by something and something, 2 things in there. What is the HCF? Both of them will be positive. Both of them are positive, so HCF is positive. HCF of 3 and 6 is 3. So I have a 3 here. X and y are both common. X squared is the smallest power, and y squared is the smallest power, right? X squared, y squared. So that means the first term, 3 by 1 is 3. So this is 1 here for now, positive 1. X squared by 1 is x squared. I need 3 y's, but I have 2. So I could just change this to y. And this term, this needs to be positive because 3 by positive 2, 3 by positive 2 is positive 6. I need a x squared by x is x cubed, and y squared by that is y squared, right? So that's it. Right? So expand as the first line. Simplify means the third line. That means collect like terms together, right? And factorize, well, you know what that is. Pulling out the HCF outside here into 2 brackets. So I hope you all got this and you'll understand what I just did.